Yes, my name is Jason Hand, and it's awesome to be here at SauceCon. Yesterday's talks were pretty amazing. I really liked the opening talk, especially about the automation with the nuclear missiles and everything. We got a few things that I'm going to talk about that kind of relate to that. So we're here to talk about cognitive bias and how that can impact your ability to continuously improve. So I thought we'd sort of just start off by talking a little bit about DevOps. Is there anybody who's never heard of this term, DevOps? I feel like this has gone around now, especially to this crowd. Like, that's a term most of us are familiar with. But if you ask 5 different people what DevOps means, you'll usually get about 30 different definitions because there's so many different sort of takes on what it actually is and what it means. So to sort of set the context, I thought we'd go through sort of a variety of different explanations of what DevOps is, and then I can sort of share with you what my sort of definition of DevOps is. So first of all, when we're talking about DevOps, a lot of it is going to have to do with the technology. So we've got out here in the just outside the doors, we've got a number of really great vendors. They're all out there, letting you know about different types of technology that they're providing and the things that they're building and interesting stuff that they're doing. Sauce Labs is certainly one of them. There's a lot of awesome technology out there, and it seems to be getting better, every single day. Along with the technology are different processes that we're coming up with. Automated testing and CI/CD, and VictorOps is an on-call and incident management platform, and we're trying to just innovate on the way we do things. Rather than relying on the way that we used to do stuff, we're always trying to come up with new and better processes. And then there's the people part, too. You'll hear a lot about how culture is such a big and important piece of DevOps, that you can't do any of these other things until you can get the people problem solved. There's a lot of different types of culture out there, and depending on the size and sort of the industry you're in, the culture of your company is going to be very different. And there's a lot of people out there that I talk to who are pretty convinced that DevOps is really just continuous delivery, being able to get yourself to that place where you can deliver on demand. You move down sort of the maturity scale of, well, we can push out stuff, maybe every 6 months, and then we can do it maybe once a month, and then you do it a couple times a week, and then maybe you get it to where you can do it several times a day, maybe hundreds of times a day. If you're somebody like, an Amazon, Facebook, they're doing it crazy number of times. They're constantly adding new stuff, taking stuff out, but they're always they're able to deliver their product pretty much on demand as they're ready. And a lot of people still hold on to that is what DevOps means. But then there's another camp of people out there who are really convinced that it's this infrastructure as code piece. Being able to create, provision, configure, manage all these different aspects of infrastructure simply by using code. Tools like Chef, Ansible, Puppet Labs, they're providing these methods so we can go out there, we can get infrastructure in much the same way we would write code. And I'm not sure if you're familiar with these two gentlemen, Paul Hammond and John Allspaw, but they kind of did a mic drop on the web operations community back in 2009 at the Velocity conference that O'Reilly puts on, where they did this presentation on doing 10 deploys per day while they were at Flickr. Well, back in 2009, that just didn't seem possible. And so they, through the course of their presentation, demonstrated how they got to the point where they can do 10 deploys per day. Now, these days, that's a pretty low number. But this definitely helped sort of shape this idea of DevOps and what we're trying to achieve and what we're after. And then sort of a more modern look at it of DevOps is that we're taking our devs and we're taking our ops people and we're trying to get them to work better. We're trying to tear down the silos. If you've ever heard Jeff Bezos' 2 pizza teams, his Amazon sort of story of, we want all of our teams to be small enough that they can be fed with 2 pizzas and they can take care of a lot of different stuff. And that's sort of the model for DevOps for a lot of folks too. And then there's a really great sort of acronym out there. It started off as C.A.L.M.S, but I think it's been adopted or morphed into C.A.L.M.S, where we've got the culture piece. Of course, you got to have that before anything will actually work. We have this strong focus on automating as much as possible. We've adopted lean management, lean practices into our thinking, things like making work visible, that kind of stuff. We become very, very passionate and just sort of OCD about measuring stuff, or at least capturing that data so that we can go back and analyze it later. And then sharing. Sharing is actually one of the harder pieces for a lot of folks because sharing means opening up. And it means sort of showing behind the curtain and taking some of the things that we think is maybe beneficial to us to hold on to because it makes us an expert. I'm the person who knows how to do X. And if I share that with others, suddenly I feel like maybe I'm not as valuable anymore. Well, that whole mindset is going away, where we actually just share and sort of transfer the knowledge that we have with everybody on our team so that we can sort of all reap the benefits of what's going on. And then there's people who say, well, we've got DevOps, that's great, but there's security in there, there's QA people in there, there's a lot of other sort of teams within the IT organization. So what about them? And of course, they all start to jump in too. So now we've got DevSec QA Ops, if you'd like. But the idea is that if developers and operations are going to start working together sooner in the pipeline, this idea of moving things to the left, we're shifting everything to the left, why aren't we doing it with everyone? Why aren't we getting security involved early on rather than waiting till the end when they just come back to us and say, nope, this isn't going to work, doesn't meet our requirements? Why don't we talk about that earlier? Why do we have to wait till it gets almost to production before you nope the project that I've been working on? Same for QA. Why do we have to wait until the end? Why can't we do all this stuff early, together, along the way? Now, what's kind of funny is that this whole DevOps conversation, a lot of it really evolved out of this idea of, well, if we are doing infrastructure as code, and so we're treating our infrastructure as though we're writing software, why aren't we taking the principles like Agile and applying that to this infrastructure? So what if we did that? What if we took Agile and we applied it to the concepts of infrastructure? And then this is sort of how we got to this white paper here, a gentleman named Patrick Dubois, who is the one who started DevOps Days, which is now all around the world. I think there's something like 42 or something like that cities just this year. I've been to a number of them already this year. One of my favorite conferences, to be perfectly honest, and it all started because Patrick Dubois and Andrew Clay Schaefer were together at an Agile conference, and they started having this conversation. Why don't we take Agile and start applying it to infrastructure? And so this white paper came from that. There's a link. You should go read it. It's pretty interesting, actually, to sort of read through their thoughts and how a lot of this DevOps stuff kind of started off. Now, there is no DevOps manifesto, unlike Agile, and there probably never will be. But as I mentioned, there's all kinds of different definitions of what it means. Now, this is my own personal definition. So if I've got a manifesto of DevOps, this is what I sort of think it is. And I'm going to read it to you. DevOps is an approach to our work where we continuously look for methods to evaluate and improve the technology, process, and people as they relate to building, deploying, operating, and supporting the value of our organization that our organization provides. Now, I want to look a little bit deeper into some of these here, both work and value, and then also the building, deploying, operating, and supporting. Oh, by the way, all we're really talking about here is continuous improvement. Sometimes that's really my definition of DevOps. When people really seem to be off in the weeds and totally confused about what we're talking about, I just say it's about continuous improvement. And that seems to sort of connect with a lot of people. So that's sort of a quick primer on DevOps. But let's go into value. What do I mean by value when I say that? Well, in our industry, and certainly the people in this room, I would believe, that the value we're talking about is the capability of delivering our product or service faster than competition, obviously, but really, it's being able to do it faster than yesterday. We've just got to get better every time, and we're looking for ways to do that through improvements in technology, improvements in process, and improvements in people. So that's sort of our definition of value within this whole thing. How many have ever done a value stream map? Anybody in here done one? Value stream maps are incredible. I don't care what role you're in. If you're at a conference like this, you're in IT to some degree, and you're probably part of a team or part of some sort of organization who is trying to develop ways to provide value. Once you have visualized the whole process from going from ideas, whether that's in somebody in the product team or someplace else, but how you get from that idea all the way out into production as an actual feature, being able to visualize that whole process, uncovers all kinds of areas of improvement. It shows all kinds of friction. It shows you that you're doing this well, but you're doing this not as well. And it gives you areas where you can go in and see if you can find ways to improve that technology, that process, or maybe the people aspect. I highly encourage you to do a value stream map, or at least go back to your teams and start talking about value stream maps, and maybe do some research on them. Now let's dive into the ideas of work. What do we mean by work? Well, we're talking about building, deploying, operating, and supporting that value, or that product, or that service. And so this is sort of what we're all here to figure out. How do we make this stuff better? Well, you make it better by simply trying to learn as much as you can and improve on that constantly. And here's a few examples of some different techniques that people have put in place to focus on the learning and figure out what we can do to improve. I've already showed you the value stream map. I'm sure most of you are familiar with and probably practice in sprint retrospectives after we're done with our 2-week sprint, 1-week sprint, whatever it is. We get together and we talk about that, what worked, what didn't, what do we change. We do daily stand-ups. We want to know, what are you working on today? What did you work on yesterday? And is there anything that's keeping you from getting that done? Do you have any blockers that me as your manager or somebody else on your team, I can help remove that? Learning reviews, that's sort of a post-incident analysis type of concept. It can also be done pre-incident. Making work visible, that's part of the lean concepts, but we use Kanban, we use different ways to sort of see all of the work that's being done or needs to be done. There's ideas of go see, which is really just management's sort of new marching orders of, I don't want to wait to find out through a third party what's going on. I need to go out and actually see the work being done and see how I can help my team remove whatever friction they have in their system. And then kata, that's just sort of the idea of just continuous improvement. If you've never read the Toyota Kata, it's a really, really fantastic book. I highly recommend it. It's got all kinds of really great ideas in there. So the point is that we're taking this really scrutinizing approach to technology. What can we do with our technology to make it better? Maybe there's a different vendor we should consider. There's a new tool out there that we should look at. Maybe we need to consider a different way of testing our software or managing our on-call experience. How do we improve those processes? And then there's the people part. Those complicated meat bags. They're always the problem, it seems like. Well, it's true. This is the hardest part, and that's why culture always comes up, and it seems to be the sort of the deal breaker for a lot of the DevOps stuff. And the reason is that for the people part, we now have this really, really strong desire to be fully transparent. We want that from our organization. We want that from our management team. We want that from everybody that we work with. We want this sense of transparency. We also want to be able to collaborate in almost extreme ways. We're used to doing projects together, but we're also used to doing projects together sort of in a silo, where we don't necessarily know what's going on with the other teams, where the operations people maybe, have conversations with the developers or the QA somewhere else after they've done their work, but they're not actually doing it in more of a collaborative way from the beginning. That's sort of our new focus. And then sharing, that kind of goes along with that. I think tools, like Slack and HipChat, the popularity of group chat tools kind of illustrate how we're moving more into this world of sharing more information, sort of sharing it in real time, and being able to have these both synchronous and asynchronous conversations about what's going on, about our work and just what's happening throughout the day. And then empathy, this is another big piece. You can't have a DevOps presentation without empathy coming up, because that is the idea. We want our development teams, we want our operations teams, the QA, security, everybody involved, they need to empathize with people outside of their division, outside of their teams, because once you start to do that, those silos do start to dissolve. I start to care about what it's like for a development person. I start to care what it's like for our QA people and the work that they do. And by empathizing, suddenly we're able to collaborate and get things done in a much better way. But then there's this one thing that we seem to always forget, that humans are fallible and that we make mistakes and that things are going to happen. And sometimes they're going to happen in very dramatic ways, and sometimes they're going to happen in very subtle ways. But we are fallible, and there are some things that I think we should try to keep in mind as we look for ways to improve the technology and the process and the people. There's this really great poster. I know you can't read any of that. And by the way, I'll have these slides available. I'll make sure that y'all can get these and look at them later. But this is definitely not all of the cognitive bias out there. If you go to Wikipedia and look for cognitive bias, you'll see tons of them. Those will be a lot of them in this list for sure. But they've, at least in this poster, they've sort of broken them out into different categories of you need to act fast. So what is a cognitive bias that happens when you're trying to act fast? What's one where you're just trying to remember details of something? Something happened recently and you're trying to juggle retrieving that memory but also taking action in the moment. Maybe you've got too much information. You're being overloaded like a fire hose of information. And how do you juggle that? What's your brain doing when you're just being overloaded with information? And then what if there's just not enough context? You actually don't know what to make of the information you have. So those are just sort of 4 categories, and then they break them down even further. And there's specific cognitive bias that they have in there, and different heuristics and associative coherencies and those types of things. So, and I'll talk a little bit more about those in a few minutes. But first I want to do a real quick experiment. Now, if you've seen this experiment before, you've seen it on the internet, you've seen it in a different presentation, don't ruin it for anybody, just play along. But what I'd like for you to do is I'm going to show you a sentence, and I'd like for you to count the number of F's. And I'll leave it up for about, I don't know, maybe 6 seconds or so, 10 seconds. It's just a really short sentence. But count the number of times that you see the letter F. OK. So how many counted 3? OK. About 6. OK. What's another number? Give me something that wasn't a 3 or 6. 5? OK. Any others? 4? OK. So we usually miss the of. So 6 is the right answer, obviously. Now, I don't know about you, but I've looked at a few log files in my day, and it kind of reminds me of this. How about this one? This one's going to be a little tougher. So I want you to take this number here, 6982, and what I want you to do is add 1 digit to each of those separate individual numbers. So 6982 is going to turn into 7093. Does everybody understand that part? OK. So we're going to take 7903, and we're going to keep adding 1 digit to each of those 4 digits. And we're going to do that every 3 seconds. Oh, you're right. No, that's right. 6 goes to 7, 9 goes to 0, 8 goes to 9, 2 goes to 3. We're adding 1 to each one.
So it doesn't drop into 1 from the 10?
Yeah, you go, yeah, exactly. 0, 9 goes to 0, 0 goes back to 1. OK? All right, so let's do this real quick. So we're going to keep adding 1 digit every 3 seconds. How'd you do? Was it kind of hard? Just kind of had to think a little bit, right? As long as you got a little coffee in the system, it's not too bad. What if we go faster? Oh, by the way, what was the last number? Does anybody remember? What? So this right here, the fact that there's literally 200 different answers, is a good example why we should be doing post-incident analysis almost immediately after a problem. Because if you wait something like 72 hours, you're not going to remember anything helpful at all. Our brains they're just not going to handle that stuff. They're just not going to maintain all of the details. We can't even remember a number that you looked at literally 2 seconds ago. By the way, it was 0326. So let's go again, but faster. It gets harder when you try to go faster, right? Like we're doing the same thing. We know the process. We're just adding a number. It shouldn't be that difficult, but it gets really, really difficult the faster you go. Oh, by the way, did you make any mistakes? Did anybody notice the obvious mistake? Most people don't. Under the constraints of time, we miss those things. We're trying to get through this in a hurry. We know we got to do this really quickly. We know we have something breathing down our neck. This is what it's like to be in an ops team, essentially. You're constantly under this sort of pressure to solve problems very, very quickly, and with various degrees of constraints. How many of you in the room are on call ever as part of your responsibility? A few people. Awesome. Thank you, my brethren. So you know very well what this is like, right? This probably is like bringing up anxiety in you already. It looks very familiar. We're constantly juggling stuff. Now, we know multitasking isn't really a thing. We try really hard, but you can only do so much. You can only do so much and maintain so much in your mind at once. Now, for those of you who are on call, I'd encourage you to avert your eyes for the next few seconds, because this is what really sucks. When you've got somebody, maybe it's management, somebody on the team, but they're constantly asking, hey, is it fixed yet? Is it fixed yet? Is it fixed yet? That's not helping. That's making things actually worse. It's adding to the constraints. It's adding to the problems. But yet it's just sort of natural part of whenever something's going wrong. And of course, we get angry. Everybody gets angry because we don't have things fixed yet or whatever the case is. And then a lot of this leads to ideas of burnout. A lot of people who have to carry the pager, they have to take that responsibility of being on call, they burn out early because they have to deal with alert fatigue. They have to deal with noisy infrastructure and pagers going off all the time and being woken up at 3 in the morning and spending the next several hours digging through log files and trying to understand what happened because development checked in something into production on a Friday, and so now I spent my whole weekend solving somebody else's problems. People burn out on that. That goes back to the empathy piece. Okay, we've got another exercise. AV team, we've got some audio on this, just to give you a little heads up here. Just a 2-minute, quick little video.
But did you see them?
Hold on. Yeah, total spoilers. Well, I don't know if it's going to work now.
Moonwalking bear.
Here, let's do this. Totally spoiled it. It's okay. It's all right.
This is an awareness test. How many passes does the team in white make?
Go!
The answer is 13. But did you see the moonwalking bear?
How many did?
Go!
It's pretty obvious. All right. So most people are like, WTF, how did I not see that moonwalking bear when it's so obvious the second time when you go back and look? That's just our mind. We were focused on counting. We were focused on the people in white. We were focused on something else, and something extremely obvious, like a grown man wearing a gorilla costume or whatever it was, walks right into the frame. We totally missed that. And again, this is stuff that we deal with as IT people, especially those who are on call, constantly trying to evaluate what's going wrong and what's happening and try to make sense of that. Now, for those of you who are on call, we all know that uptime is huge. We try to maintain this idea of 5 nines availability. And we have SLAs, service level agreements, and different people who expect our service to be up and running maybe all the time, 100%, never have any problems, which is a very difficult thing to do, especially if you're trying to innovate. If you're trying to make your own technology better, you go into this defensive posture. Don't let anything happen to the system. Don't put in any new code. Don't change anything, because I am incentivized to maintain 5 nines. You're incentivized on checking code in. I'm incentivized in saying no. So that's the problem right there. But we're always going through this balance type of thing of efficiency and thoroughness. where we're trying to find the most efficient way to do something, but also be as extremely thorough as possible. I've got another challenge for you here. Read through this sentence real quick, just to yourselves. Okay, everybody got it? Pretty easy. Just reading colors out loud in our minds, I guess. So, you know the sentence, you know the structure, you know what to expect. We should be able to read this probably in like half the time, right? If we were to do it again. All right, well, let's do it again. This is known as a Stroop test. It's much, much more difficult to get through this simply because the first time we recognized there was an association with the color and the words. And I've taken that away and, in fact, flopped it around on you, and you couldn't read it as quick. You couldn't get through it in the 5 or 6 seconds like you did the first time. This, again, is that brain trying to make sense of the new information and be thorough, but also get through it very quickly. I encouraged you to read it faster. I showed you that you've already read this sentence. You can do it quicker. But then our brain had to sort of react to the new model, to the new information. A lot of this has been sort of explained in terms of 2 different systems within our own psyche, within our own brains. There's the fast system, and then there's the slow system. In fact, there's a really great book called Thinking Fast and Slow that I highly recommend. It's a pretty dense book. Maybe you get the audio version of it. But it definitely changed my sort of perception on a lot of things. And one of the things that came out of there is when you're talking about these 2 systems, there's system 1, which the author refers to as kind of more like shallow work. So system 1, a good example, I think, is when you're driving. I mean, this happens all the time, right? You're driving to dinner, you're driving someplace, and before you know it, you're there, and it didn't even you didn't even really have to think about all the turns you made, using turn signals, there's a lot of stuff that happens that we just sort of do. We don't even have to think about it. Our bodies just do it. And then there's system 2, which requires a much deeper look at what's happening. We have to actually analyze the information. And we have to sort of slow down a little bit. This is the deep work stuff. And this is a great quote from Daniel Kahneman. I'm not going to take the time to read it, but it's a really, really awesome book. I do suggest you read it. And a lot of this is just really pointing out that under certain circumstances, we start to rationalize rather than seek rationality. We just look for these mental shortcuts, desire paths, if you would. If you've ever been you see these on campuses a lot, where there's a sidewalk going this way and a sidewalk going this way, and there's like a dirt path that goes right between the 2 at an angle, because nobody wanted to go and take a right angle walk just to get to class, so they just go right through the grass. You start getting hundreds of people doing that every day, suddenly there's a path right through the grass. That's what our brain does too. It's a desire path. It takes a shortcut because it sort of knows what it's trying to accomplish. So anyway, this is just my little plug for that book. Really great one. Definitely highly recommend. And so if we go back to this idea of availability, reliability, trying to get those 5 nines of uptime, there's a lot of people sort of within our space, within our industry, who have moved away from this idea of taking a defensive tactic where we're trying to predict and prevent things from happening, because turns out it's just not possible within IT to actually prevent problems. So why don't we just get really, really good at knowing about them and then fixing them really, really quick? And that leads us to a metric of the time to recover. And then of course, how does that look over time? So you look at your mean time to recover. But how quickly can you recover from these disruptions? That's sort of our new focus these days. We're not trying to have minimized downtime or try to increase our mean time between failures. We don't want to go 300 days without some sort of problem. We actually understand there's going to be problems, and we just got to be really good at fixing them. There's another really great book that came out last year called Site Reliability Engineering. It's kind of put together by a bunch of people at Google. It's a really great book. It's got some really innovative thoughts in there. One of the ones I love the most, I think, is error budgeting, which is essentially accepting that we have SLAs, but if you look at your SLA, let's say it is 5 nines, and if you look at that per month, well, maybe that allows you, without breaking your SLA, that allows you about maybe 30 minutes of downtime. So that's sort of our new focus. I have 30 minutes. I can actually break the system. I can push it to its limits and see if I can come up with some new way of keeping the system stable. And if you keep it within that 15 minutes, you haven't broken your SLA, and then there's your error budget. So you can go in and start pushing the system a little bit more. Anyway, that's a really good book. I highly recommend that. Take it with a grain of salt. A lot of the stuff they talk about in here is specific to Google. Google has Google problems. We do not have Google problems. But it's a really good one nonetheless. And a lot of the book is really just, again, kind of the idea I just mentioned, is that we're trying to recover quickly. But most importantly, we have to learn from that. We have to learn from our mistakes. We have to learn from what the system does under, quote, normal conditions. Complex systems is what we are dealing with, right? We're not dealing with very simple mechanical systems. We're dealing with software that runs on silicon, that operates in the cloud. There's all kinds of stuff. Even just the idea of our users, that adds a level of complexity that sometimes we forget about. But one of the things about a complex system is that there is never a root cause within complex systems. We still do these RCAs, we do 5 whys analysis to try to figure out what the cause of a problem was, but usually that's just an estimate. It's not really the cause, because in a complex system, things are constantly changing. There can't possibly be one single thing. Whatever may have broke or failed under very unique circumstances, happened in a very special way. It may never happen again. Systems are always changing. That's sort of the most common default property of a system, is that it's constantly in change. And as that, things are going to fail, right? We're trying to push new code out into production. We're trying to get things out there for users to use, and sometimes we miss bugs, and sometimes network switches fail, and sometimes AWS goes down, and sometimes there's always something, right? There's always something that could cause a failure. So failure is what we sort of just accept as a normal part of an operating system, of just systems in general. But we do want to understand, maybe we see that there may not be a cause here, but there is some correlation. We know that cause is only available in a linear system. A linear system, if you think of like a set of dominoes, there's that first domino that falls over, and then one by one, the rest of the dominoes fall over. That's a linear system. There can be a cause. In a nonlinear system, the stuff that you and I are working on, there's not a cause. There's correlations that we want to identify, and we want to look for contributing factors. This happened because of this, which caused this over here to happen. It's more of a systems thinking approach, where we view the sort of the bigger picture rather than trying to isolate that one thing. But causation and correlation also can play tricks with us as well. I don't know if you knew this, but the per capita consumption of margarine has a direct relationship to the divorce rate in Maine. Also, mozzarella cheese and civil engineering. Okay. And then thank goodness that Nick Cage didn't have a movie between 2003 and 2004, because pool sales were up that year, it looks like. So it's easy for us to find causation and correlation even when it's not there. We have this ability to be extremely confident, but extremely wrong, because our brain just wants to find patterns and wants to find things that may or may not actually be there. Here's another example. So this is James. James is very shy and withdrawn, invariably helpful, not much interest in people or the world of reality, meek and tidy soul, needs order and structure, and has a passion for detail. Now, how many of you would say James is a librarian or James is a farmer? How many people say he's a librarian? Okay. And then B, farmer? Okay. So what typically happens to us in a situation like this is that our brains sort of trigger this resemblance heuristic. Based on the data that I gave you, the information, how I explained James, you may have thought that James was one thing or the other. But did you actually try to use rationality to figure out the truth? There are more than 20 male farmers for each male librarian in the United States. So although I described somebody that sounds like a librarian, they were actually a farmer. So this is a good example of a heuristic. It's one of those mental shortcuts that I mentioned. Now, I've already sort of touched on the idea of post-incident analysis, these ideas of learning reviews after something bad has happened. These are perfect for spotting that type of bias. It's very easy for us to not notice our own bias. But as we get together in groups and teams, you can start to spot that in other people. You can say, oh, Jason, I can't help but notice you just said, I should have known better. That's a hindsight bias. Thinking that we could have known what would have happened ahead of time. There's only one way to know that, and that's in hindsight. And so for us to think, oh, I should have known that, I would have done this instead, or we've fallen victim to a hindsight bias. And those are hard to find in ourselves, but they're easier to find and spot in other people. So what is a post-incident analysis exactly? This isn't a talk specifically about post-incident analysis, but if you're not familiar with it, I thought I'd give you a little bit of detail. First of all, you get this is all happening after some sort of failure with a system, some sort of problem. You've had like a severity, Sev 1, Sev 2 maybe problem where it's actually impacting the bottom line of the business, and so you want to do. A lot of people call them postmortems. I like the term postmortem sometimes, but that sort of insinuates that we're just here to discover the cause of death. But actually, we're here to try to learn. We're trying to improve things. And so the first thing you do in a good post-incident analysis is that you want to invoke the space. And maybe it becomes repetitive, and everybody's like, yeah, I get it. Well, we're not here to find cause. We're not here to point fingers. We're not here to blame and shame or get anybody in trouble. We're here to learn. So invoke the space. We are here to learn, and that's our main agenda. And then from there, you start to construct a timeline. You want to know what happened specifically and in what order. Something broke, somebody was paged, they came in, they started doing this, they reached out to that person. You actually start to develop a very granular, detailed timeline of what took place and understand, some of the things that we did. I went in and I ran a command and that seemed to help, but then 5 minutes later I did this and that didn't help at all. But we're trying to recover very quickly. So you want to analyze literally everything that happened during that timeline. And then as you go through that, you can document, well, here's what we learned. It turns out I went into some log files and did this and found out that this was maybe the problem, so I then logged into another server and I ran this command. But as we're going through that timeline, maybe somebody else on my team points out, hey, the way you did it's not wrong, but there's actually a better way to do this. And so we wouldn't know that if we hadn't discussed that as a team. And so we document all of the different things that we've learned about the timeline and how we can maybe actually improve things moving forward in terms of recovering very quickly. So establish those learnings, and then from those learnings, we want to create action items. We want to put something into our ticketing system like Jira and say, okay, here's what we're going to do. It took 5 minutes to find Jason, and it looks like maybe something has to do with his paging policies. It just took us too long to find him. So we need to go in and adjust that. So I'm going to create an action item in Jira that says Jason's going to go into VictorOps and he's going to adjust his paging policies so that we can find him quicker, so that we can recover from this problem a little faster. And then a lot of it has to do with taking those actions and then giving them some real priority. If we just come up with our action items and they go at the bottom of a backlog, our system is just going to have the exact same problem when something like this happens again. We're not actually able to recover any quicker because we didn't actually take it further. So we're trying to reduce the time it takes to recover. And there's, within the timeline, within sort of the story of what happens, there's 3 different phases to that. There's the detection phase. There's the response phase, where we're actually trying to get together and triage and investigate what's going on. And then you get into the remediation phase, where you're actually fixing things. And by digesting and dissecting and taking a really close look at the timeline, we can see, well, it took only a few minutes to know about the problem, but then it took a really long time to actually recover from it after we finally found somebody. And you can see, well, we're not too bad in detection. We actually were really good in response, but man, it took forever for us to remediate that problem. So maybe there's some areas in here that we can improve. So I know this is a little tiny and hard to read, but these are some of the more popular cognitive bias that comes up. Our confirmation bias is that we have this tendency to find information in a way that confirms our own sort of perceptions of what's going on. The hindsight bias I've already mentioned. I'm going to skip down to the bottom one because this one's relevant to that story we heard yesterday, and I think maybe interesting to many of you, is the automation bias and our tendency to excessively depend on automated systems, which can lead to erroneous automated information overriding correct decisions. I think that applies directly to our Russian friend who seemed to have canceled World War III for us. But these are some of the more well-known biases and things that we look for in different ways, but definitely in a post-mortem or post-incident analysis. Let's look at some other stuff here in the few minutes that we have. Actually, I've just got one more thing I want to show you, and then we should be wrapping up here. And we have the same problem here. So let me back this up. All right, start from the very beginning.
Count how many times the players wearing white passed the ball.
We've done this before, right? You guys are good at this.
Count how many
Sorry,
times
that was my
the
fault.
players wearing white passed the ball.
A little easier to notice in this one. Okay, everybody count?
The correct answer is 16 passes.
How many got 16?
Did you spot the gorilla?
Did anybody spot the gorilla?
For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it. But did you notice the curtain changing color for the player on the black team leaving the game?
Anybody see both of those? Yeah!
And watch it again. Here comes the gorilla, and there goes a player, and the curtain is changing from red to gold.
We just went over this. How did we screw this up? It's cognitive bias. It's our minds. We're focusing on something. I gave you a new task. You're like, I got this. I can count that ball. I know there's going to be a gorilla. Not fooling me this time. So, kind of in closing here, cognitive bias is kind of one of those topics that I think slips through the cracks in a lot of conferences and a lot of just sort of conversations. We're people. We make mistakes. It's something we have to keep tabs on and try to find ways to improve that. Like I mentioned, a lot of the DevOps sort of ideals and the principles is that we're constantly learning. We're trying to find ways to improve the technology that we're using, the processes that we're implementing, and then the people part, because there's always going to be that people part. And like I said, that's often the most difficult and hard part to solve. And the fact that we do have these natural biases is something I think with a little bit of effort we can spot those and we can sort of avoid them or at least consider them. So that's pretty much all I have to say about cognitive bias. I'll be around all day, so if you want to chat in the hallway or something, definitely grab me. I've got a couple of books out here that are not related to this topic, but one that I do other talks on quite a bit, and the topic of chat ops. Anybody familiar with chat ops? Is that a term? No? Okay. So done a couple books on them now. It's really taken the idea of using all of the tools that we use in a day-to-day basis. And we already, in most cases, are using group chat tools like Slack and HipChat, FlowDoc, or whatever, IRC. But what if we take all those tools and we put them in the conversation? So we have the context, and we're able to maybe run commands from within Slack or wherever we're at, and be able to interface with literally everything we do in the same place that we're having conversations about that. It's a really neat topic. I think it's kind of fascinating. It's sort of the way a lot of incident management teams are doing, managing their different failures of systems. And then sort of related to that, I'm actually in the middle of, I turn it in next Wednesday. I turn in the final draft of my new book with O'Reilly on post-incident analysis, learning from failure, which I think is something that also people just don't take seriously. They a lot of times they go in and they try to do a root cause analysis. They try to do some sort of post-incident analysis, and all it ends up being is a memorial of what took place and who should we blame. and maybe we'll come up with a corrective action that may or may not fix things. Usually they don't. But there's a better way to do post-incident analysis, and that's to try to learn as much as you can and come up with actionable items that we can assign people and prioritize work and all that kind of stuff. So look for that book. That'll be out July 15th. And that's pretty much all I've got. Follow me on Twitter. Definitely share anything that you may have seen here today. And I'll be around most of the day, so love to chat with you. So with that, thank you very much.